Hi, well, thanks everyone for some great talks for week 2 on reliability at scale. We're going to have some live Q&A today. So my name's Amaya Booker. I'm a technical program manager in infrastructure at Meta, and I'm going to be facilitating some questions for all of the speakers today. If you have any questions to ask, please feel free to add them to the webinar and we'll bring them up. So let's go around the room. We've got a few people. We've got Fred and Kewei from Meta. We've got Huiba from Alibaba and Craig and Sam from Google. All right, excellent. All right, so I'm going to start with a question to Fred. This is a question near and dear to my heart. You know, when we're thinking of hardware monitoring at this kind of scale and really looking at monitoring on every machine, you know, that comes at a cost. So, you know, what did that look like for you in terms of, you know, the total cost of adding this monitoring? And was there anything that you chose not to do because of that cost?
Thank you, Amaya. Fred, I'm a data science tech lead manager at Meta Infrastructure. To your question, like you said, there's always a cost, and we are always trying to strike a balance in between, the overhead that we introduce for monitoring and detection versus the benefits that we get, right? That how are we detecting failures earlier? So what we do as a methodology is just to put things together into an equation. So mathematically, you have the cost and you have the benefits. What we are trying to optimize for is the overall availability. So you have a target, you have a top level metric that you try to optimize. And then with this cost and benefit, we can find an optimal spot for this equation. But of course, you don't always have those numbers sitting there very clearly for every action and for every event. So sometimes we do need to make estimates. But then again, we need to have a top level metric. And for us, from the infrastructure side, that would be the availability to our services.
All right, great. Well, you know, that's what we're here to talk about today is reliability. And so, you know, certainly there is always a benefit to those kind of costs. All right, we got one for Huiba. You know, thinking about your new container image system, you know, what was the startup time improvement that you saw?
That it has been deployed at scale in Alibaba, namely all applications of Alibaba that needs acceleration are currently using DADI, and all container-related products provided by Alibaba Cloud have an option for DADI.
All right, fantastic. And anything coming up new on the roadmap for DADI?
On one hand, we have donated the DADI to the community, and we hope more and more users will be using it, and potentially making it a de facto standard, next generation standard. And on the other hand, we are trying to integrate that into our Elastic Block Service and making it a basic feature of Alibaba Cloud.
All right, fantastic. Good to see that getting out into the public space. Fantastic. All right, here's one for Kewei. You know, often when we have failures, you know, particularly at the infrastructure level, it's common for, you know, a lower level failure to cause a failure on multiple products. What do you do about collecting signal on each product that has had an issue and deduplicate those concerns?
So we're actually, when the federation was very first run, we did run into a situation where our monitoring is on per product level, and we have an infrastructure failure that suddenly created maybe 10 or 20 different regression tests that people are freaked out about, and they thought something was wrong. And then eventually we realized, okay, those situations are going to happen, although they're going to be much more rare because our infrastructure are generally much more stable. So our solution was actually to use use machine learning, very, very surprisingly there. What we did was we're actually correlating all these tasks and figure out, okay, what is the trend between all of them? And if there is a similarity across all of the products, what we're doing in the background was we're saying, okay, let's pause all of the tasks on each of the product level, because we actually believe there is something wrong at a deeper level. And we would notify people like us who is overseeing the entire product federation across the entire app. And from there, we can go out and then find the correct service owners that may like misconfigured something or have something overloaded that affect a lot of products. So that was our solution, and it has been working pretty well ever since we stopped creating hundreds and hundreds of tasks for situations like this. Yeah.
Yeah, no one likes a task storm when there's been a big incident. So, as somebody who's spent time in my career doing manual root cause analysis across these kind of trending, I know, how time consuming that can be. Did you actually get any time saving about using machine learning?
Absolutely. So the correlation things, and we have our data scientists help us to do precision and recalls, right? So because what you need to do is to do time patterns corresponding to different services and their metrics. So basically, they would help us like order it in terms of what does this model think is most likely the root cause, so that it saves us a lot of time to like go over maybe hundreds of different services, but in the order of what is the most likely. And typically by the time we went to the fifth one, we found the thing. So it definitely saved us a lot of time there.
Great. I feel like this is just one of those kind of chores that, it's not everybody's fun piece of engineering, and it's great to see machine learning really tackling these things at this kind of scale. It's fantastic. All right, so Craig and Sam from Google, we've got a couple of questions here for you. So, it sounds like you had a lot of components that you kind of integrate into a single product. That's never easy at the best of times, particularly when you're sort of working with components that have maybe been in existence for some time and written by other authors. So, what were the biggest, technical challenges you had on that integration journey?
We were lucky that we didn't actually have that problem. All of the components were created effectively by the same people, effectively at the same time. So we had thought this through a little bit. I wouldn't go as far as to say that we had planned that we were ever going to bring them back together, but we didn't have to worry, for example, about things that were listening on the same port and having to move things around. What we did actually do, though, is we did it in two different phases. The first phase, we brought all of the things together into the same binary, and we were still doing somewhat bodgy things to have them communicate. So it would open a connection on localhost to the port that the old service would operate on. We would still have the different parts of the application making individual calls out to the Kubernetes API server. So we were doing things that were expensive, but that worked. And then once we'd validated the idea and seen that it worked for people and we knew that we were happy with it, then we were able to consolidate again some of those things and call things internally where it made sense and break things down so we weren't communicating separately as if they were separate services, but bring them back to get that real benefit.
Sam, anything to add?
No, I think that basically covers it.
All right, okay. We've actually got a live stream questions just come through for two of you. So is it recommended to use ISTIO for rate limiting applications based on infrastructure usage?
Yes, so Istio does have rate limiting features. Having a better and more robust API for rate limiting has been something Istio has been focusing on in recent quarters.
All right, fantastic. All right, we got another live stream question here for Kewei. How is your federation approach related to the agile approach of cross-functional teams owning end-to-end value delivery and operation? Oof, that's a mouthful.
Yeah, I think this is a really good question. And I think we definitely see a lot of similarity towards the agile approach. I think one of the difference here is when you're operating at a bigger scale, where a lot of the services are going to be owned by teams that are a little bit distant from you. Maybe they're not one arm length away that you can have that cross-functional relationship built, right? They're maybe like three layers away, maybe in a different organizations. So having a federation approach actually is an education opportunity for our developers. So think about a product engineer who is like using all of these services, and their assumption is always going to be, things are always going to be available. When I call this API, it's always going to be there, right? They don't actually understand what are some of the failure mode that might be possible and kind of write their code in a much more robust way. So doing a federation, we actually give that opportunities for people to educate themselves, like let them know that, oh, here are the services you might not be very familiar with, but here are the kind of metrics that should represent the failure mode. And then like kind of being an education and help them to familiarize with these things. So yeah, I would say like from a vertical versus the horizontal approach, this is much more similar. But in terms of like ownership and how much of XFN work that you can do, a federation kind of help you with that.
All right, fantastic. All right, going back to Fred. You talked a little bit about some of the dimensions that you were monitoring in your talk, and you sort of mentioned hardware, components, the vendor, and then the service. After you've done sort of these key components, what do you recommend people start looking at next?
Yeah, there are a lot of attributes to our hardware, like firmware versions, kernel versions, the specific model of memories or hard drives or SSDs, anything that could really lead to failures. I didn't mention this in the presentation, but those dimensions don't have to come in this specific order. So you can look at maybe SSD versions or firmware versions first, and then the applications and so on. And so that's why we have built this fast and scalable dimensional analysis that's very specifically designed for this at-scale analysis to look from like hundreds of these attributes, which ones are the most relevant to our target failures in our analysis.
All right, great. I'm going to actually throw this at a couple of you mentioned open source technologies. So can I just ask, what were the sort of pros and cons of using open source in this sort of environment? Start with Craig.
We are in a space that is dominated by open source. I don't think there's ever any suggestion that the thing that we were going to build would be anything but. And we see that as being true not just of infrastructure software, but say, for example, startups today. There are very few companies who are building stuff in the cloud native space that are not completely open source. A lot of people might do an open core model where they hold things back, but on the whole, we're seeing people move to a model where the product is completely open source and the thing that people are charging for is either support or hosting of that thing in the common use case. So it's just, in some ways, it's an assumption. Like the open source is well and truly one, at least in this space.
Huiba, you mentioned some open source work as well.
I'm sorry?
Any pros and cons you'd like to mention of working with the open source software in this environment?
I'm sorry, English is difficult for me. Kewei, can you translate for me?
Yes. So the question is, 对于开源项目来说，你觉得就是用开源项目有哪一些好处和哪一些不好的地方？
Thank you, Kewei. We got a real international group today.
Yeah, thank you. Open sourcing, open source software has a lot of advantages, and for example, we can use we can reuse many existing technology from the community, and so we can have a very good start point, and there's some for cloud computing providers, open sourcing is also has disadvantages because cloud providers, the product of cloud providers is essentially technology, and open sourcing may it is also open sourcing is also open their technology to the community, and competitors may also use that technology.
That being said, I should point out that Alibaba Cloud have an Istio-based product, the Alibaba Cloud Service Mesh. And so that's exactly what we want to see when we open source something, is we want to see even people who in some ways could be considered in a competitive market, bringing together the best of this technology, contributing it, and rising the tide for everybody.
Yeah, absolutely. I mean, I'm very encouraged to see this group today of people across different, organizational boundaries coming together to work on this kind of technology. And, I believe that open source is our way forward for this kind of collaboration. It's great to see. We've got a couple more live stream questions to come in. So actually, they're both for Fred. So the first one is, are we exploring opportunities to implement anomaly detection using either out-of-band telemetry or, analyzing data closer to the platform?
Out of band for sure. We're doing anomaly detection on anything we can get, right? And then that becomes a different issue of how do you reduce the noise from there. But yeah, I mean, data is everything, and we definitely have that. I didn't quite get the second part, which is closer to the platform.
Yeah, so can we consume or analyze the data that's on the platform, say using DPUs or IPUs is the question.
Okay, I don't think I probably don't have the context to answer that. But we do, again, we collect a lot of data from the servers, from the out-of-band, and just push them to our centralized database and do some post-processing and anomaly detection, and then root cause analysis. Yeah, so that's basically the flow we have.
Well, the next question is actually a pretty good follow-up to that. And that was the question is, does that provide enough data for you to train your machine learning model?
Yes and no. There's always a lot of data. So one thing we need to do is first do feature engineering to reduce the noise and that kind of stuff. But on the other hand, if you look at the complexity of our environment, right? There are so many server models and so many firmware versions and so many kernel versions and so on. And so if you group all these dimensions into smaller clusters, each cluster may not really have that many data points. Right? So it's again a trade-off between how general or how generic you want your model to be trained on. If you want your model to be trained on the entire fleet, then yes, we have a lot of data points. If you really want very specific models trained for specific cohorts of the servers or jobs, sometimes we don't even have enough data points. Yeah.
All right, well, I'm going to ask one last question of Sam, and then we'll wrap up. So, we have a lot of people who are coming from smaller environments, coming to watch the at-scale events. And, there's always one question that comes up, which is, how does this apply differently at different scales? So, thinking about sort of a lot of the approaches for reliability engineering that we've talked about today, how does it really differ at scale versus if you're in, say, a smaller shop?
Yeah, so the deployment models that you have available to you when you're deploying Istio, they can look pretty different based on how large your organization is. And maybe if you're a smaller company, you have the same group of people operating your Istio deployment as you have deploying your applications. At a larger company, you might choose to completely separate the deployment of Istio and abstract that away and just leave the service owners with the minimal possible knowledge about the mesh. So that's one aspect that can be pretty different.
Excellent. Okay, well, I want to thank all of the speakers today for their excellent talks. And, if you missed any today, we do have the recordings appear on the website later on, so you can see anything that happened today or even from the first week's worth of sessions. Thank you again for all of the great content and taking time to be part of our Q&A panel. I know it can be a little nerve-wracking for sort of live fire questions, so thank you again. And remember, for everybody else, we have week 3 coming up in a week on the 22nd. So feel free to come back, join the webinar, or watch some of the videos on our next week's Systems at Scale. Thank you.